Hi and welcome to this short clip going through the reactivity trends assessment question, including the long answer one at the end, which many people found a bit tricky. So I decided to do this clip to help people sort of go over it at home in advance of your progression exam. So the assessment question pack contained a multiple choice question, a bit of group 2 and also some group 7. So let's start at the beginning. Which statement is not correct for group 2 metals? It's really important to remember that you're looking for an incorrect answer. Now luckily in this case, looking at each individual answer, the first one you come across happens to be correct because an unpaired s orbital, or for an unpaired electron present in an s orbital, suggests an s1 configuration instead of an s2, which would mean a group 1 element. So because the question asked us which statement is not correct, this must be the correct answer. Okay, so let's go on to the next one. Now, if you look at the first question, it says a student prepared some calcium hydroxide, and you'll notice I've put CaOH2 above the calcium hydroxide. It's always a really good idea when you get a reaction described to actually put in the equations or formulae for the individual components of the reaction, because it's essentially telling you what to write. If you notice at the bottom of the screen at the moment, you can see that obviously you have to write an equation. So by writing in the formula for each species that's involved, that enables you to think about what equation you're going to write. So let's start with our observation. We know that a metal reacting with water is going to produce a hydroxide and hydrogen gas. So that would mean you'd see an effervescence of some kind, or bubbling. So we could write effervescence, bubbling, or gas, or fizzing, or something to show that you understand that a gas is being produced. So provided you give all words to that effect, that would be fine. In addition, the solid calcium metal would dissolve. So you can write out the equation like that, and you need to double check, because calcium is a group 2 metal, it needs 2 OH minuses to react with. You'll need to actually balance the equation by putting 2 H2O in. So now we can move down the page a bit. So it says to decide which row is correct. So each row has 2 separate strands to consider when you're doing this: highest pH versus reactive halogen, with both parts having to be correct. So we know that fluorine is the most reactive halogen, so now we need to decide which one has the highest pH when added to water. So if you think about what a high pH actually means, it's the fact you've got a high concentration of OH minus ions. So the metal oxide you choose must be able to dissolve in and react with water fully instead of partially. So barium fits the bill because it's more reactive than magnesium, so the answer must be barium oxide. This will mean that if we choose barium oxide and fluorine, our only option is answer C. So the next one, where it says chlorine gas can be added to a cold dilute alkaline solution to form bleach, you've got 3 things there you need to think about the formula for. You've got the chlorine gas, the fact that dilute alkaline solution is OH minus, and bleach is the chlorate 1 ion, ClO minus. So if the sentence gives us this so far, we now need to think about what happens to the other chlorine, because it's obviously not balanced for chlorine. So this is again recall, a benefit and a risk of chlorine in water treatment. So the 2 most simple answers are there, but you could also say that compounds of chlorine are formed which are carcinogenic. I would recommend just sticking to Cl2 as toxic because it's easier to remember. Now this next part is where quite a few people struggled, so I'm going to slow down a little bit and try to take my time here with this. So moving the page down, it says, a student carried out test tube experiments to prove the trend in reactivity of halogens. It gives you a list of the things that the student is provided with, and it says chlorine gas and chlorine water are not available. So I'll put a red box around that because it clearly means that there's something about what they want you to do that doesn't involve using chlorine gas or chlorine water. And it says the student carries out the minimum number of test tube experiments using these solutions in the presence of cyclohexane, an organic solvent. So I've squared that one as well because it's important to remember that when you're doing your answer. So looking at the whole thing, you can just check that it's 5 marks that we need. So, state the solutions that need to be added together in order to prove the trend in reactivity of the halogens using the minimum number of test tube experiments. So from the reagents you're given, you need to think about ones that obviously aren't going to react. So in other words, what they're trying to say is you don't want to waste time. Then it says describe the colour seen in the organic solvent at the end of each test tube experiment. So in other words, what halogen is going to dissolve. Then it says write an ionic equation for one reaction that takes place. So not all of them, just one is enough. So the only possible combination would be bromine and calcium iodide. Any other combination is either putting a halogen with a more reactive halide, which it can't displace, or it's putting a halogen with its own halide, which it wouldn't react with anyway. So there we've got our ionic equation. Okay, now this obviously proves that bromine is more reactive than iodine, but you need to also do something that won't react just once to show that you can see something isn't reacting. So let me try and explain this. We need one more pair of solutions that shows that the halogen that dissolves in cyclohexane this time does so because it's not able to displace the halide from solution. In other words, it's less reactive. So remember this time, choose a pair that will mean the halogen dissolves into the cyclohexane without reacting. So, looking at the options we've got, the solutions to choose would be iodine and magnesium bromide. So the reason for this would be that the iodine dissolves without reacting this time, not because it's been formed from a displacement. Now obviously there are other possibilities, and not too many of them, but they are possible, provided that you follow the guidelines we've been looking at as we go through this.